All right, so help me understand what you've built so far for the capstone project here.
Okay, so for our capstone project, we've built this radar front end, which is to be attached to the front of a vehicle. And the intent is that it will scan an intersection as the vehicle approaches for any obstructions or other objects. And the intent is for users to be able to bypass an intersection if there's no obstructions or other vehicles. It does that by using frequency modulated continuous wave radar. So it sends a chirp signal which bounces off of the object in question. The chirp signal is received, and then we do a frequency analysis, which you can see on the monitor here. This is just the FFT. And we can actually track peaks in here. It's rather noisy right now as we've been having some performance issues, but we can track peaks which directly correspond to objects in the path. And from that, then we can make a decision based on that whether or not the user can pass through the intersection. The reason we want to do this is because with all the stopping and going at intersections, there's a fair amount of extra wear and tear on the vehicle, as well as extra fuel costs. So we're looking to reduce those by providing a technology that allows users to safely pass through intersections.
Any challenges you faced? Time constraints, perhaps?
Yeah, there have been some time constraints. Probably the biggest challenge was some of these radar components are rather finicky. So we've actually encountered a problem where, as you can see here, we've got a lot of noise and interference frequency-wise, which makes it difficult to get a really clear signal of, as far as objects in the intersection goes. So that's probably been the main challenge, has just been noise and interference, trying to filter that out and mitigate as much as we can. But this is just the version 1 prototype, so there's definitely a lot of improvements we can make in that regard, and hopefully we'll be able to have a better system in the future.
I see you have a publication over here.
Yes.
And
well, it's just a little paper that we wrote, just outlining the savings that can be saved if you're allowed to bypass a single stop sign.
Yeah, there's plenty of copies here. You can take one if you like.
If you like, you can take one for yourself. But at the end, like you can see here that through our calculations shown in the paper, you save at least 308 million liters of fuel each year if like only half the cars in North America could bypass a single stop sign. This translates to also over 600 million kilograms of CO2 emissions, 3,500 brake tags, collectively over 1,501 years in time.
And it's all because of the system.
Yes.
Vehicular object detection solutions. Yes. Awesome. That's the poster. I wonder, like, how long it took you to complete the project. Full 1 year? When did you start? In year 2, year 3? This is the final year capstone.
Yeah, so the course is a year-long course. Although as far as hardware goes, that's been the focus of the second semester. So that would be from January until now was more of a focus on hardware.
Any specific tools you used to design the hardware?
A lot of the simulation was done in MATLAB because radio frequency simulation is a bit difficult, so it's good to have a good processing tool like that. As far as all the low frequency stuff like the amplifier, the modulator chip, power supply, that sort of thing, all the simulations for those were done in multisim. We do have simulation results if you're really interested, but basically a lot of the lower frequency stuff is fairly simple, a lot of passives, so it wasn't too difficult to simulate multisim.
Would you have a live simulation or not set up at the moment?
We do have this running right now. You can see the output right here. The trace, I can
Let's do the trace.
Sure.
We can do the indication lights too.
Yeah, that's on trace. Okay, so you'll notice it's locked to the lowest frequency here. That's one of the problems we've been having. Ideally, this line here follows the path of objects in front of it, and then it updates this interface, which is just a simple yes or no, pass the intersection or not. If nobody's standing in front of it, it should lock to green, or just be super noisy.
It's picking up everyone.
Yeah, it's picking up everything behind it.
Yeah, because there are so many people behind me that's moving, so it does make sense.
But it does. It shows green if it detects no objects in front of it, or if the objects are moving away. and then it shows red if there's objects moving towards it or stationary ones. And that's used as the notification to the driver to pass through the intersection or to stop.
Perfect. So, wishing you all the best for the later judging. And I'm really impressed. I love it.
Okay, thank you.
You're welcome.